Good morning.
Good morning. Welcome to Hydronic Solutions with air to water heat pumps. Turn a couple things on here so everybody can see me.
There you are.
Perfect. Good morning. Thanks for joining us. Again, welcome to Hydronic Solutions with air to water heat pumps. We're going to talk, it's going to be a little piggyback from last week if you joined us and joined Anthony and myself with the low temp high efficiency last week. My name is Rick Koester, so I'll be presenting today. We got Anthony in the background, so kind of flip roles this week. He'll be answering any questions you might have, interacting with you guys. So again, this is a conversation. We're going to talk about some heat pumps and all kinds of things from heating, cooling, even domestic hot water at some point later on. But again, you got any questions, throw them in that chat. Anthony will be happy to answer them. Anything we don't know, we got a couple other smart guys in the group, we'll be able to get that answer to you at some point. If you can, just throw in the chat, where are you joining us from today? We always like to see how far we're going, who we're talking to, who we're interacting with. We did give you some handouts today. We got 4 of them in the box, so don't forget to click on those, download them. I think we got 2 heat pump brochures. We got the Space Pack, which we're going to talk about a lot today, the new Takeo unit, as well as the Takeo full line catalog, and more importantly, our line sheet, right, with our contacts. So that's something you'll see on the bottom of the screen there. I have our Instagrams. That's myself and Anthony there. If you're on Instagram, feel free to follow us. We love interacting on there as well. We spend a lot of time seeing what you guys are doing, checking out your installations, posting your installations. So if you have something, tag us in it. We'd love to share it with our manufacturers. It's just another great avenue to really reach out to you guys and just stay connected. So like I said, we're going to talk about some heat pumps today and piggyback a lot of what we did last week. We talked about low temperature, so hopefully listening and learning last week, if you did join us, you feel a little bit more comfortable with low temperature hydronics or just heating it with low temperatures. So we're going to talk about that. So as we kind of get started here, we're talking about water, right? And that's something that we know a lot. And I see a couple people in there, Quag, Andrew, beautiful. So we've got some good people on today. We talk about heat pumps and air to water heat pumps in general, right? Why is water such a great heating, media, you could call it, right? And you look at heat pumps in general and what we can do with hydronics. It's very flexible, We can utilize this with many different, terminal units, right? From baseboard, low temperature baseboard. We can do radiant heating, hydronic air handlers, panel rads, and we'll talk about a lot of them. We'll look at a couple of them later on. But it's just very flexible. And it works very well with your existing heating system. So if it's something that we want to, maybe just piggyback with our boiler, whether it's cast iron oil, whether it's gas, it doesn't make a difference. It works very well as, a secondary heat or auxiliary heat, or maybe even your primary with your boiler now becoming your auxiliary. So we'll talk about that and show you some diagrams. We can provide at this point heating, cooling, and domestic hot water. And we're definitely going to touch on that domestic hot water because there's some cool things there. Show you some diagrams on how we would pipe something like that in. But the heating and cooling aspect of it, we could do very, very efficiently. This one is probably my favorite, when we say why air to water, right? I don't know about you, but I've been doing this now 21 years, I want to say, with my Darby career here now and being out in the field, doing installation, service, and all that. I have not seen a phase out of water at any point. Right? Water is water. It's not going to change. You look at the refrigerants that we're using today, we're going through a new, we just got comfortable with 410A and we're now going through a phase out, right? They're going to, in the next couple of years, no more 410A. Well, what's the next one, right? So when you look at the long term, you install a system, they're not cheap anymore, right? 5-10 years from now, what's going to happen if that system needs a major repair and that refrigerant is no longer being used, right? So that's something we always got to be mindful of. With water, it's not going to change. It's been like that a million years. It'll be there for another million years, hopefully, right? So water is always going to be the same. We might add a little bit of glycol, so we have some things to worry about there. But other than that, the equipment can change all at once. The water and the media is going to stay the same. So it's one of the benefits I like a lot about air to water heat pumps and just using water. And if we're talking heat pumps, we definitely have to talk about COPs, right? So this is our efficiency of our systems. You're going to see some numbers today that are pretty impressive. If you joined us last week and you heard Anthony discuss, COPs a little bit, You know, a COP is nothing more than, you know, you pay for $1 of energy, or you give me $1 of input, I'm going to give you $1 output, right? I'm going to give you $1 of energy back. So that's 100% efficient. You can compare that to electric base load, right? You get 100% of what you put into it. Heat pumps a little bit different. We get a little bit more higher COPs, we'll call them, right? So 3, 4, and maybe even 5 COP. So if let's call it 3, right? So you give me $1 and I give you $3 worth of energy back, that's 300% efficient, right? So, you know, just understanding how that works and why it's a good thing. These also work hand in hand with rebates at some point too. So it's always good to know what you deal with. So as we get into, you know, some of the components, we're going to go through, we're trying to keep this very basic, you know, as we go along, and we're going to ask some questions here. If you guys are, you know, can definitely interact with us. We'd just have some fun with it. But, you know, are you currently installing air to water heat pumps? Have you installed one? You know, what was your experience? Was it good, bad, negative? You know, whatever it was, we'd love to hear about it. So give Anthony some work back there, and so let's see what you've got. But the components of the system, I mean, what you guys already know, and that's really the goal today, is to take what you've already known and what you've learned even last week. You know, if you're doing boilers at this point, it's another, you know, question. Are you a heating company only, or are you also doing cooling? So if you're a plumber right now and you're trying to get into that cooling industry, right, this is a very easy way to do it. One of the things I didn't put on the screen was, you don't, because of that no reclaiming and not touching the refrigerant in most cases, we do not need a refrigerant license, you know, with some of these units. So if you're looking to get into that cooling side and you know hydronics, this is a great way to get in there. You know, I tell it all the time in the classes that we do with Space Pack and just air to water heat pumps, you know, right now with the phase, you know, the phase out of gas in the city and then where we are in our territory and fossil fuels kind of, you know, being pushed away. I got guys trying to start, you know, a whole air conditioning division, and last time I checked, labor is pretty hard to find these days, right? So trying to start a division and build your company up to compete with some of these guys that have been doing, you know, mini splits for the last 20 years, it's going to be very difficult for you to succeed. But if I can show you a product like you're going to see today, which really incorporates everything that you've known, everything that you've been doing, it's just a little different, right? We're changing the source. So we want to take what you already know, change the source up a little bit, and you should be rolling from there. So let's look at some of the components. And this is our little hydronic space pack house, but it works for all, you know, anything hydronics in air to water, really. So we make up of a couple of components as I stumbled. But outdoor unit, right? So we got our heat pump. This is something that I think, you know, a lot of our homeowners have really come to accept, you know, especially because of mini splits. This is not really that much bigger than a mini split system, you know, as far as the outdoor condenser goes, you know, a little bit bigger, but quieter. You know, I've seen these run, you know, at full capacity. Like 90 hertz is really it's an inverter piece of technology, right? So it can ramp up and ramp down. At the highest it can do, it's still so quiet, and you can have a conversation next to it. It's very comparative to a mini split condenser. You're going to have your outdoor unit, so that's going to be different than what you're used to now if you're doing boilers. And then you're going to we'll go into our buffer tank, which we'll talk a little bit about. So that's going to maybe not so much if we're going to keep a boiler, it's going to, you know, go hand in hand next to the boiler, but that could replace your boiler, right? That's going to be our battery. And then we got our terminal units. So you can see off the piping here, we got a radiant manifold, and we'll go into a couple different things here. We're going to touch on these all later on. But we got what we call a high and a low wall or a thin wall. We got some low temperature baseboard, which I know Anthony talked a lot about last week, right? So we know we can do that. And then a hydronic air handler up here as well. So this is something else, small duct high velocity, right? So we do have hydronic air handlers for that. And then we can't forget the radiant heat down here. So that's always low temperature. So those are our three major components of the system, is from our outdoor unit to our buffer tank, and then from our buffer tank to whatever that terminal unit may be. You know, and that's up to you guys. And what it really comes down to is the load of the building, right? The envelope of the building. How many BTUs? And if you paid attention last week, you know, it's not so much the temperature. You know, and that doesn't worry me, temperature. What worries me is delivering the BTUs needed to satisfy that load calc. So before we can pick all of these different components out and figure out what's going to work best in your application, we need to know what is that load calculation? What is that? What do we need to accomplish here for comfort? We do have some great services right on the Space Pack website. There is a design what's the word I'm looking for? Design services, we call it something else, pre-sale support, right? That's where you have the ability, if you have a set of plans for a home or a building or a project you want to explore with air to water, we get that information up there, and we can get you the form, or you can get the form right off the website, fill out some basic information, email the set of plans, and they'll come back with the load calculation done for you, and somewhat of a material list. We can help you out with all of that as it kind of progresses towards your project. So take a look at that. But
more information, better.
Yeah, more information, absolutely. You want those details. Window schedule is huge, the type of insulation, they're pretty good. They do this all day long, but they need information. So the more you provide, the more you get back. It's a good way to put it. So as we start to look at some of these heat pumps, that we work with here, on the SpacePack side, we got 3, really nice systems at this point. We got 2 monoblock systems and then a split system. So starting with the monoblocks on the left there, right, we have the Solstice, that's going to be out 3 and out 5-ton units, right? So you can see some of the numbers there, and if you take a look at some of those COPs we were talking about before, right, we're up to 5.01, and there's a little star there, so we got to understand what that's coming from, and 4.67 looks like, a little far for me to see, but those are high numbers when we talk about COPs and heat pumps. Right, so we need to understand at what water temp that is, what outdoor temp that is, right? These are design conditions in most cases. So we want to see how many BTUs we're actually getting out of the system. Are we satisfying our load and getting those COPs? If that's the case, then this system is going to be very, very efficient. Moving over to the system in the center there, that's our extreme unit, or our low ambient unit is what we call it. That's down to minus 22 degrees. Great system, just started popping out, last couple months, available to order. So you can see some of those numbers there, some good performance. That's a 4-ton unit, yet we're getting about 62,000 BTUs of heat. And again, we need to know what that outdoor temperature and what water temp we're delivering there, but up to 62,000 BTUs and a COP of up to 5.4. And even that EER number, that's an electrical efficiency ratio, if you understand what that is, those numbers are pretty high as well. The last system we have with SpacePack there, you'll see the inverter split. This is where we have to play with some refrigerant now. So this is a little different. The big difference here, even on the water side, a little less glycol than what we're used to using, because we don't have a lot of water outdoors now. Most of it, all of it is going to be inside the building. We have our outdoor unit, which that looks very similar to our LAHP, and then we have our indoor unit, which looks like a wall-hung boiler, but that's our air to water, refrigerant to water heat exchanger in there. That's going to be our pumping and all of that stuff. Your refrigerant lines will connect the two. This comes as a system, so you will get the line set, the control cable, everything you need to hook up the 2 of those together, and then go from there to your buffer tank. So even that system, that's a 5-ton system, up to 71,000 BTUs for heating, up to 5.2 tons of cooling. COPs down a little bit, closer to that 300% range we were talking about, right? 3.09. And again, you can see in our manuals, our submittals, all of that stuff to see what those temperatures are, and based on your design temp and the water temps you're going to deliver, we can get you, a little bit more accurate numbers at that point. But great systems, again, very quiet, very efficient. These systems can be paired together, so that's something that, with newer controls that are coming out, or just offsetting some temperatures, we can play friendly with, multiples and stuff like that, which is nice. And then we got our newest system out there, and it just came to us from Takeo. So this is something we've been working with, Anthony and I, and John Resso on the New Jersey side. I don't believe Jim and Rob get up there. I don't believe they did, but we've been getting up there as a group and bringing some contractors with us. And this is a system that's going to be very interesting. This is for passive homes, very tight homes, small, not small envelopes, but small loads on those envelopes. We had a gentleman last week, was it last week? I believe he was talking about 2,500 square foot homes with loads of about 20, I think it was 20 to 25,000 BTUs. And that's where this is going to be that perfect system. You can see up to 44,000 in heating, 3.5 tons cooling capacity. We do get some domestic hot water out of this. You compare this with, an optional, you can put an indirect off of this, an 85 gallon is something that they can supply with. But you can see the piping arrangement makes this very, very easy. You know, if you're a plumber or you're a boiler guy, you know, very, very easy to deal with, right? Ins and outs as far as our domestic ins and outs as far as our heating, and then from our heat pump outside. So I guess we can compare this. What were you saying? Like a refrigerator size is probably a good way to think about the size of the units themselves, inside and out.
Yeah, like an apartment size of refrigerator.
Apartment size of refrigerator. You can see outdoor temperature range down to -7. So we had the -22 on the space pack side. -7 still more than enough, you know, for heating, and then up to 113 for the cooling side. So good numbers. COPs up to 4. So again, you know, depending on your application, the water temps, the BTUs you need, you know, we can look at those numbers and get you more accurate. But this is going to cover most of your outdoor heat pumps that we do have here at Wales Darby. So some good solutions. Moving on to the next component in that system, the buffer tanks, right? They're BTU batteries is really all they are, right? They're hydraulic separators. They give us 2 different flows, or we can do 2 different flows is what I should say, from our outdoor unit and then our indoor. So it's a decoupler of the Hydronics system. That's all it is. Another thing I like to say when we talk about buffer tanks is it's always cheaper to buy the storage than it is to buy making the, you know, you want to buy a new outdoor unit or a second outdoor unit and put that on the side of the house, or do we want to put a second storage tank and store more BTUs in that? So that's something, again, depending on the application, space in a room, mechanical room, right? So all of that comes into consideration when we start sizing buffer tanks. But you know, one of the nice things with the new inverter technology is we don't have to go with as big of a buffer tank, you know, in some of these residential applications, because we can ramp the outdoor unit down to match our loads. So that is something we weren't able to do in some of the older systems. So we had larger buffer tanks, and again, you know, having more storage is not a bad thing if you got the space for it. But that's all a buffer tank really is. So we'll look at some of the piping arrangements going forward and really point out how this thing is operating and how we size it as well. So this is a chart from last week too. I think you had this up there, right, Am?
Yes, I did.
Load temps, right? So, you know, you look at all the terminal units that are on here, or all the water temps and where we should be as far as radiant goes. You see us space pack, you know, air to water, really not air to water, but a hydronic air handler. We got panel rads up here. Everything underneath it really covers any type of radiant heating. We get traditional and cast iron radiators and baseboard on the other end. Those are our high temp, but we should have another one here for low temp baseboard. You know, our manufacturers today, you know, Slant Fin, Embassy, anybody that, you know, produces baseboard is giving you now some sort of chart that's showing you low water temps, you know, as far as entering, or average water temps. So if we look and we understand how that works, and understand, like last week, you know, we figure out how many BTUs we're getting per foot at that lower water temp. As long as we're matching that load to the room, there should be no problems with delivering that comfort. So some of those terminals, you know, the terminal units that we talked about, obviously the radiant you sort in the house, the air handlers, right? The other two that were kind of hidden there that you might not have seen before, which are great units. We see these a lot. Right over the West Coast, they use them a lot. But again, something that's pretty relatively, you know, accepted now by homeowners is the mini split hook. And that's exactly what this is. But instead of refrigerant, we're pumping water, whether it's chilled water or heated water, right? We can do heating and cooling with this unit. We just got to provide some sort of power source to it. I think 115 volts. From there, we could do this as a standalone too. If you have a boiler currently and you're looking to just put some heat in a basement, you know, we can pipe this in, you know, with a mixing valve if you want the low temp, or we can do high temp. So it's a good unit to take a look at. And then we got our, what we call our thin wall, which looks very, very similar to a panel rad, but it's got an ECM blower in there, very efficient, very quiet, got a nice glass front with a touch screen on there. So I think we did some math with this, you know, we were able to, at certain water temps, replace up to 19 to 21 feet of baseboard, I think it was something we were calculating.
It's considerable.
Yeah, so we, you know, you think about that, and that was like the mid-size unit, you know. We have some large ones coupled, I think 5 different models at this point, but depending on that water temp, whether it's coming from the air to water unit or something else, we can definitely do some good things with that. So, you know, as far as terminal units, you know, we really just need to know how many BTUs they're able to produce at that water temp, and then understanding our load in the building. If we can match it, we can do it all day long. So looking at the basic piping side of everything, right? So when we talk about, this is where I think a lot of guys get, a little hung up on, how does this work? Is this a geothermal unit? We get water from the ground. Like, how does this air to water work? It's a sealed system, just like your current boiler system is. Again, we're taking what you've already done and we're just changing the source, right? We're moving it outside. So we have our outdoor unit right next to me, kind of covering it here. And then we got our buffer tank over there on the far left. I want to say it's far left, on my far right. And then we're going to use a hydronic air handler in this case. It doesn't have to be an air handler. Again, this could be going to a radiant zone. This could be going to a low temp baseboard zone, whatever you choose. But we have two systems here, really. We have, to break it down for you, we have our heat pump side, right? So really all that heat pump cares about is maintaining a certain temperature in that buffer tank that we set, right? So just like any other storage tank, that's all that heat pump cares about, is maintaining that temperature in the tank. It doesn't care what zone's calling or how many zones you have or what temperature the zones are. None of that comes into play. The heat pump just cares about what that buffer tank wants, right? From there, we have our second system, which is our system side, right? That's going to be our terminal units, right? So that could be anything we just talked about. So if you can understand how that works, and now maybe you see that separation in a buffer tank, and how that kind of hydraulic separation happens, we can have two flows, which is nice. That inverter side, the heat pump side, the red piping, I might be flowing 10 GPM through there. I might have a radiant zone calling that's only giving me 2 or 3 GPM. So I can pull the 2 to 3 GPM out of this tank, while flowing 10 on the other side. So it's one of those things, just like a hydraulic separator. Buffer tank's just a little bit bigger, and it adds the storage feature, right? So we add those, we keep those BTUs in there. Think of it as a battery. When a battery starts to deplete itself, it needs to be charged. That's where our heat pump comes in. We can start to pick off of that as we need. There might be instances on micro loads, depending on how small you're running your loads, those zones might come on, and you might not even have a heat pump come on. It might not even activate once because we didn't pull enough heat or energy out of that tank. So you think about that. We don't even have a fuel source really burning just to satisfy that load. So it's a possibility. So some of these designs and some of these projects that we've worked with, and we'll go through a couple of these. And if you have questions, please throw them out there. If you see something that jumps out with, to you, definitely, get it out to Anthony, and we'll cover it, go back to it. But this is a project I'm actually going to go take a ride up to after we get done here today. This is a basic system with a boiler involved. This is 2 air handlers covering a first and second floor, right? Hydronic space pack, high velocity. We have a little Modine heater up here that's covering our garage, so giving them some heat in the garage. That's exactly what we just saw. The only difference is we're running 2 heat pumps here instead of the 1. These 2 guys, all they care about is that tank there, and then these zones just pull as needed, and we'll look at the wiring diagram to this in a little bit. But adding the boiler there, the boiler helps us a couple different ways. Number one, it's taking care of our domestic hot water, our indirect load, and then at the second side of it, it's working as a backup and even a boost. So on those colder days, instead of making making the heat pumps do all the work, we have the ability to turn that boiler on and just give us, a little bit of a help there. And this way, we take the load off of those heat pumps and then make them satisfy that load a little bit quicker. So we have that ability to do that with the different control strategies we do have. So it isn't very complicated when you look at it. It's pretty simple. It's very easy to do. And like I said, the only addition to this was really the buffer tank and the heat pumps, right? So the boiler was doing it before, and then now we got dual source, if you want to call it that. So back up,
and piping.
It's all pumping and piping, right? So here's another one that kind of gets into the domestic side, right? So I love this diagram because this is a very simple, and this is, definitely something that you guys should be able to achieve, right? So we're not using a boiler in this case. This is 100% electric. So we got our heat pump outside, taking care of our buffer tank here. There's a little bit different of a setup here as far as the piping goes, and now we're utilizing we're still utilizing a 4-pipe setup of a buffer tank, and there's different configurations depending on your application as far as 3-pipe or 4-pipe. But what we're doing here is taking those hotter temperatures and also feeding right off of the top of the tank our radiant zones. So right here, we got 3 radiant zones. And then we also have a flat plate heat exchanger that's doing something called preheating an electric water heater. So if I can deliver 110 degrees to that water heater and I have a 130 degree set point, that element in that tank isn't doing much work, right? So the efficiency of that electric water heater is going to be a lot higher than what it would have been without the heat pump there, right? So if we had to heat that tank up constantly with that element, we might not have that, the storage capabilities of that tank that we do now. I think this is an easy piping layout. You're covering your radiant, you're covering your domestic load. We're not talking about cooling at this point. And I believe the next slide will show us, if we add the addition of cooling. One of the concerns I had when I first saw this was, all right, having that domestic load come on and have cooling at the same time. And this is really the way to kind of combat that, right? So we go from the heating side, and really we could just add a second buffer tank, right? So now we have a heated tank and we have a cooling tank. So we're doing this, just adding a tank and adding a 3-way diverter valve here. So if we did have a DHW call, we needed to get some tank tap up in here in the electric, right? This little valve is just going to divert its way and put all its heat into this guy, and we'll get that signal out to the heat pump to go into heating. Then once we're done, we'll switch that reversing valve, go into cooling, and now we can supply the lower temperatures, 42, 44 degree water into this tank and satisfy our cooling air handlers. So realistically, in this application, we could get heating and cooling at the same time, which is something nice. I think I would like that, some cooling and maybe some warm floors at the same time. Wouldn't be too bad. But this is a nice, easy layout if you start to look at all of these. Wiring wise, as we get through, and I'm just going to back up before we get into the wiring, right? So I talked about before, you think about these buffer tanks, these tanks could be, if you looked at it, maybe I'll even go back to that buffer tank slide real quick. I think I had the small guy on here. Yeah. So that tank there, the one on the right, I want to say that's a 50-gallon, and correct me if I'm wrong, I would say the one you would have a display unit, yeah, the Argosy. So yeah, that's a large 50-gallon tank. The guy on the left there, that's a new addition to the space pack line. That's a 13-gallon buffer tank, right? So I talked about, the sizing side of it and volume of the system. So there is a calculation for that, but when you look at the inverter technology now and how low we can go, they were actually able to come out with a smaller tank like this, and it does have that little electric immersion heater in there as well, which is really a nice feature for a buffer tank. Gives us a little bit more, capacity. We can boost it up a little bit quicker too. But this is a small little tank, 13 gallons, and we go up to, what are we up to now with the space pack side alone? It's got to be 60, I want to say. I want to say it's probably close to 60 gallons on that. But we do have, and then Argosy, we definitely go up a lot higher. But these are different options depending, again, cheaper to buy the storage than it is to buy another heat pump. Are we looking? I see a bunch of questions popping up. Good conversation.
Thanking your BTUs.
Thank you, BTUs.
Yeah, with storage.
Okay. Good. Got some good people on. I see some names up there from last week too, and thank you guys for joining us. So we start to look at some of the control side, the control side of what we do here with the heat pumps. Again, it's very simple. Whether you're doing your own wiring, you have an electrician coming in to do the wiring, basic connections, right? We're going to look at the control side of it. We need a dry contact to turn a unit on and turn it off, right? So open and close. And then we have a dry contact to tell us whether we're heating and cooling. So it's on the control side, very simple. 4 wires go into a control you're going to see in a few seconds. Very easy to control. We do have some other contacts there if we want to do some auxiliary stuff, but that's going to be your basic layout on most applications is your on-off and your heating or cooling or reversing valve. So those are both dry contact, low voltage wires. And then on the line side, we're talking 4 wires. We got our 220, right? Our 1 and 2 there, and then starting from the bottom. So we got 1 down here, 2, that's our second leg of our 220. We're gonna bring in a neutral, and then we're gonna bring in a ground. Right? So we bring in a neutral because behind this little bundle, and I didn't circle it because we can't really see it, but behind this bundle, there's some circulator terminals there. So we power our circulator for our heat pump directly off of the heat pump itself. So we need that neutral there and a 120 leg. So that's already pre-wired into the system. You're just making your connections there, running them into the building. So there is some wiring going on there. Like I said, if you're doing your own wiring, this is very easy. You know, if you get an electrician in there, it should be very easy for them to follow. You know, we do have some nice schematics, which we'll take a peek at, but we do all of that with this SSIC control. So this is a SpacePack interface control. This makes things so easy when we talk about, you know, understanding what's calling, you know, getting to the boiler side of things, and we'll look at it, like I said, that diagram coming up more in depth, but we got the boiler contacts here. Let's see if I can get a little easier. So we got our boiler contacts here. We're doing a backup. We got our outdoor unit, so this is our on-off, our reversing valve, so that's our heating, cooling. And then you'll see we have up to 5 zones, and that's gonna be our input signals. So whether our air handler or our baseboard or whatever it is that's calling, we're gonna send an input back to this unit so that it knows and it can tell the heat pump, all right, we're in heating, we're in cooling, we need to maintain this temperature in the tank. You'll see that the sensors are all gonna get hooked up to the top left here. We got an outdoor air sensor, we got our buffer tank sensor, we can sense our return temps, right? So all of this will help with the heat pump operation. We can set some outdoor temps there too if we want to do, you know, different shutdowns and drop some temperatures just like we do with outdoor reset. So very easy to operate. It is a control that is built right at SpacePack's facility up in Massachusetts. So it can be customized to our application, and when there's updates, we download them. There's a little USB plug, we plug it in, we can update the control as needed. So very easy, very, you know, very nice to work with this control because of that flexibility of working with the manufacturer and being able to control it however we need. So we have a lot of fun with that. So when you look at it in a diagram, again, this was that that was the dual heat pumps with the NTI boiler as a backup and covering the domestic load, the hydronic air handlers, right? So that's this wiring diagram. So, and you can see, you know, there were some changes made, you know, before we got going with the job, but, you know, very simple as far as the layout. And this is a layout that we provided. It's something I put together for the contractor, for him to follow it. We can help you guys out with it too, if it's your first time doing heat pumps or even the wiring side, control side of things. But this is multiple heat pumps, backup boiler, very simple, you know, a couple 2-wire, you know, low voltage wires being run from the boiler to the control. You can see that SSIC is up here in that top corner. You know, not very difficult here. You know, everything has a landing spot. Circulators, again, this initial diagram, we ended up moving to, you know, wiring these things, 2 separate pumps to each one has its own dedicated circulator. So those went, and we changed that up a little bit. But utilizing something else you guys already know, Taco zone control, right? So we got our 3 zones coming in, and we got our hydronic air handlers as well as our modine. Going to some zone valves. You know, our air handlers are providing a signal back to the SSIC to let it know if it's heating or cooling, and to also open up those valves. So again, very basic when it comes down to the wiring side of things, very easy to operate. So this was this gentleman's first time ever putting in an air to water heat pump, as well as an NTI boiler and everything else, and high velocity at the same time. So he kind of jumped all in with everything. And he did a phenomenal job, you know, just following some diagrams and reading an instruction manual, something that we don't do a lot of today, but very, very nice. The newer controls too that have come out, you know, and from the past, we used Corel controls, which are a little difficult to get in and operate. The newer controls that are coming with our heat pumps, a lot different, you know. Now we're working with a touchscreen display. This is a nice control. We can leave it in the outdoor unit. It is a remote control, right? So remote control meaning it sends signal and it reads. It doesn't need to be part of the system, right? Once we send all the parameters, it doesn't do anything else but basically give us information back. It doesn't control the system. It doesn't run the system. All of that's done in the boards and everything else. So we're programming everything. And again, if you're a mini split guy, you've done mini splits before and you know remote controls, we set everything from the remote and then we can take that thing with us, right? Same thing here. I can remote mount this into the mechanical room. We give, I want to say it's 600 feet, or we could go up to 600 feet, get how much we provide, but the wiring is there for the control side of things. But we can put this in a mechanical room, or again, you know, do you want to be that guy that has to show up every time there's a problem? Take it with you, right? Don't tell a homeowner, you know, that they're gonna, nobody else is gonna know how to work on it but you, which could be a good thing. Typing away over there.
Yeah.
Jeff.
We are in the studio, Christiana.
All right.
She's asking about the internet.
Okay.
So I have a good question here, and it's probably getting deep into the woods for this discussion.
Okay.
Can heat being removed from the space in cooling mode be used for heating, domestic water, or space heating?
Can heat.
So it's like rejection or absorption.
Yeah, right.
Instead of bringing it back outside, you might need that phase change still.
It's interesting.
So why not reclaim heat energy, leave cooling, but now what do we do with it?
Yeah.
Yeah, it's another set of heat exchanger, reducing water temperature outside again.
Yeah. Well.
We need that sponge, I guess.
Yeah. I mean, I guess it depends on the arrangement too, because if we're talking dual buffer tanks, you know, I don't know if that really helps us, but it's interesting. Yeah, for us, I mean, I think, you know, where they're going with that is a lot of geothermal and stuff like that, and you see a lot of that there.
I always say you're limited by your creativity.
Yeah, pretty
But
much.
I have to see it on paper.
Yeah. Hey, that's a conversation. Send us an email. Continue that all day. But looking at the controls, like I said, touchscreen, very easy, gives us a lot of information. You can see the screen you're looking at is our home screen. It's kind of giving us our temperatures, our supply and our return temps. We can get into some kind of, you know, the reading side of everything where it's going to kind of give us, you know, our set points. We go through all the programming here and adjust everything we need to do, and it's in plain English, which is nice. You know, in the past, you can see very similar to the R09, R10, you know, all of these things. You know, you trying to figure out what that meant was a nightmare. Where now we get a description. All right, this is our minimum cooling set point. This is our maximum. So we can kind of play around with those numbers. We can play around with our pumping and how we do that. You know, there's a lot of different parameters in the system. Take a look at the installation manual on the website. So all of that's done right through this control. So it makes it very, very easy. We still got, okay, I see talking solar now too. So bringing that into it.
Yeah, Jeff's in a unique arena with his builders.
Jeff is down south, right? So Jeff had the 2,500 square foot projects, I think, last time.
Maryland area.
Confirmed. Yeah, I think you got some unique applications down there, you know, where, you know, we might
He's
not.
a kid in a candy shop right now.
That's right, Georgia. Very good. Yeah, I mean, this is, and I'd love to talk to him more about, you know, the takeoff side of things, right? The heat pumps on their side with the low loads that they have, you know, there's probably a lot of what you're talking about going on in that system behind the scenes, you know, where, you know, what we're doing on the space pack side, and you see the system that we talked about today and the hydronic and the parts and pieces and all that, it's more of a build it, you know, a Rector set, right? So we're customizing it and putting it together, where the takeoff side of the world with the heat pumps, it's a system. We're not modifying anything there, right? This comes as a complete package, put it in place, run your refrigerant lines or your water lines, I should say, you know, put it all together, and that's the way it runs, right? Where space pack, yeah, we could possibly be more creative. You know, you have different applications. I have a gentleman now in up in Ashbrook, in North Shore, Long Island right now, who wants to try and utilize groundwater, you know, and all of these radiant fields in his driveway coming into this. You know, it's a little different application of what we're seeing, and I think that's just overcomplicating it, and we're trying to squeeze out some efficiencies where, you know, I don't think the value is there, you know, what we're going to see. So we can be creative, we can have some fun with it. we can keep it basic and simple, you know, and I think that's the easiest for servicing down the road. You know, anytime where, you know, yes, put in all this in and all the controls and all of that, who's got to go back and fix it when, you know, when something's not working properly, right? Is the average guy in your company going to be able to go there and understand exactly what's going on? So trying to keep it simple, and I'll even back up to, you know, something like this. I mean, this looks complicated, but it's really not. You know, if you took these systems up here, these radiant manifolds away, you did that as 3 low temp baseboard zones, right, off of this tank, you know, it becomes a little bit more simpler maybe in your head, right? You know, the application. We got a buffer tank, we got 3 baseboard zones, we got an electric water heater next to that buffer tank. All we're doing is a flat plate heat exchanger, another circulator. It's, again, Anthony said before, you know, it's pumping and piping. You know, if you understand that, and I think we do that pretty well with Taco and Uponor, right? We were pretty good at sizing and then figuring out the circulator you might need. We can help you out there 100%. You know, it just simplifies the system so much. You know, yeah, there's a lot of different valves and stuff like that, but
To simplify, even having one of those manifolds,
yeah,
and depending on the flow and the loads, it could be panel rads.
yeah,
You can have a manifold just home running out to panel rads.
yeah. There's some good. If you guys hit the website, hit spacepack.com. There's a section in the hydronic area called Waterworks, right? And that's a publication with the help of John Sigenthaler. They did a great job. I want to say there's probably a dozen different little reading, I don't know what's the word I'm looking for.
Additions,
Yeah, additions, little
different topics.
yeah, each topic is maybe 3 or 4 pages, 5 pages the most, right? But you can sign yourself up there, they'll send them all to you, or you can download them in a PDF. But you can kind of get into a little bit more of these applications where you might see the panel rad set up, you might see, you know, more in tune to what you're looking to do. Maybe open your eyes to something you never thought about doing, and again, spark that creativity a little bit. But this is a basic setup, you know, and if I even go back to the first diagram, the basic setup, this is even simpler, right? So it's a couple pipes there, 2 pumps, and an air handler. So if you do have those setups, you know, even your own home, you know, start with something like this. You know, this would be a super efficient system at that point electrically, and as far as the cooling and comfort side of the Space Pack High Velocity, you put the 2 of them together. This is something definitely, you know, I'm really excited to put in or look at putting in my own home. High velocity with the air to water. And again, you know, we could incorporate a boiler, start throwing that into the mix, but very easy.
Did you discuss distance with underground piping at all?
That's a good point. I didn't want to bring that up. So you could see, and this is probably a good slide to do it from, right? So whether we want to be right up against a house where traditionally we see condensers, or you want to be, you know, in the woods 100 feet away, you know, whatever the case is, depending on your homeowner and the application, right? You're only limited to the pumping and piping, right? So yeah, we might have to run a bigger pipe. We do have some underground, we call it EcoFlex from Uponor. So that's something that's a direct burial pre-insulated pipe. So that's something cut to, you know, basically order to what you need, custom lengths. But, you know, we don't have to be, you know, 50 feet away. We're not limited to like refrigerant as far as line set lengths and height requirements and all of that stuff. We, you know, it's again, creativity. How far do you want to go? Yeah, we have a pump for it. You know, is there a cost? Absolutely. But we do have the abilities and capabilities with all of our pumping to probably hit that.
Universal hydronics formula.
That's it. Yeah, we know that. You know, we can.
With the glycol, we tend to go heavy just because we think it's more safety.
Right.
But read the chart, read what your protection gets down to. It doesn't take a lot, but that does affect your pump sizing as well. And always remember, glycol is a maintenance item.
That's it. You know,
It doesn't last forever.
Yeah, I like what you said, the heavy, you know, I hear guys 30%, 40%, you know, and you think about the, you know, fluid freezing or whatever the case is, you know, it's burst protection, it's all of that stuff. But even when you have a, call it 10-degree day, you know, a 5-degree day, that's not fluid temp, you know, that's air temp, you know, that fluid is not getting there. So just because you might hit a couple 10-degree days doesn't mean we need, you know, protection at minus 22 degrees. You know, it's not, or even at 10 degrees. You know, the glycol's not there, and I think that's an adjustment Space Pack made too. You know, I know initially when the split system, and that was, go back real quick, when this guy here came out, the split unit, we said, all right, great, we got no water outdoors, right? We don't have to put glycol in the system, but we do still need glycol in the system. We need just enough to keep it from freezing in the flat plate heat exchanger that's in the inside box here, right? So there are some, you know, opportunities, I'll call them, where those refrigerant temps can get low enough to freeze the water if it was straight water in that heat exchanger, and that's something we want to avoid, right? So not going to kill it, but it's still something we want to avoid, right? So we need that flow. So we want to go with a little bit of glycol, just enough to protect it, and that's it. And that's going to help. That's going to help with your temperatures. That's going to help with your BTU capacity, right? And obviously, the more glycol we're putting into that system, the less piping, less we can pump it. So now we need bigger pipes and bigger pumps and all of that stuff. So
I got something from the peanut gallery here.
Yeah.
Glycol survives a lot longer in heat pump systems simply because it doesn't heat degrade.
I like that. And that's something, yeah, that's something I never thought about myself. So you didn't hear that, right? So heat pumps, you think about putting glycol in a boiler and having a flame, you know, I guess that's really
Lower temperatures.
Right. So higher temperatures will start to degrade that glycol, where a heat pump, it's not going to see that kind of abuse, really, is what it is. Who shared that with us today?
David from F350 Dooley.
Oh, David, appreciate that, man. So that's a good one. So that's something, I learned something today too. So that's one of those things you don't think of, but yeah, glycol is one of those things where it could.
It's still a maintenance thing.
Absolutely.
But not as much. So under severe conditions, you know, just like anything else, revenue stream is good. If you don't maintain what you install, someone else will.
Absolutely. Absolutely. Yeah. It's when you can just watch water quality, and it's same thing with boilers. It's not just heat pumps, right? It's everything. So we're dealing with hydronics, we're dealing with metallic parts and pieces. So we don't want to heat them up.
So I put a question out there, didn't get really an answer, but what makes heat pumps so efficient? Right? Just to kind of put a broad statement, and to say is we're extracting free energy, outside air. Refrigerant today allows to absorb in a -10 temperature, heat energy,
right?
And now we can transfer that into our homes, our buildings, using refrigerant to water.
Think about -22 degrees. There's still enough heat in the air to absorb, right? So it's one of the great things about heat pumps, more accepted now. You know, again, did anybody, you know, has anybody been putting the heat pumps in? Was that something that was answered?
I don't believe so.
No. Okay. So like I said, if this is your first time and you're a little curious and you're not sure how to apply it, you know, reach out to myself, Anthony, Jim, John, Rob, you know, on the New Jersey side. You know, we work with these hand in hand. Like I said, I'm going up to a job site after this. You know, we're seeing it a lot more, getting a lot of commercial applications popping up. You know, we got a tennis club that wants to incorporate air to water, get rid of their propane heaters. You know, we got New York City parks we're going to go take a look at, walk their jobs. They got some stuff they want to convert air to water from their oil. So, you know, there's definitely some waves being made with air to water heat pumps out there. And I think residentially, with the way these systems operate, I mean, it makes sense. You know, having a backup, for sure. We like redundancy, so why not have that oil boiler or that gas boiler, whatever you want to call it, you know, as a boost or a backup. See a couple more questions there.
Yeah, I lost it there for a second.
Jeff, we were all headed to, yeah, CO2 is definitely something that's being talked about, Jeff. You know, I was up a couple, I want to say maybe a year ago now, we were up looking at some larger commercial units, air to water heat pumps, some big guys, and you know, that's the conversation. You know, CO2 does give us some great features, right? It'll give us higher water temps if needed. But, you know, like I said, you know, we talked, and you saw Anthony's presentation, hopefully last week, we talked about low temperature heating. You know, if we need 150, 160 degree water, yeah, you know, I would like to see CO2 for one reason. I can take care of all my domestic needs at that point as far as domestic water. You know, I don't really want the high temperatures for heating, but I would love to see them just to satisfy the full domestic load instead of preheating, right? So you got some new stuff. So he's put in a couple. Good.
Yeah, saying he just installed a monoblock, and thank God I didn't have to charge it.
Yeah,
CO2.
exactly. Yeah, we're talking some crazy pressures, and it's there's always a danger of what we do. So safety is always got to be something we look at. But yeah, CO2 is definitely a viable answer there. You know, I
What's
like
that picture there, Rick?
So great question. That's part of the questions, right? It's what was hopefully somebody would have asked about the back wall, but right. Thanks, Ant. Appreciate you. But yeah, so this is, you know, this is our low ambient. If you were at our event 2 Wednesdays ago at this point now, I want to say, right? So we had a nice event over at Wales Darby in Islandia. So we featured this piece here in a Space Pack booth. We did some good training that day. But that's our low ambient heat pump in our training room, our Islandia facility. So we got some great low water, pricey low water options below, low temp, I should say, heating on that back wall. But that comes from our Belgium friends over at Yaga. They make some great stuff there, trench heaters, stuff like that. Those red columns, yeah, those red columns are heaters, low temp, as well as that nice decorative piece in the back there. So if you have not seen one,
Heat wave.
pretty cool. So it's a heat wave?
Yeah, it's concrete piece of art with stainless steel tube, from small to extra large. You can actually grow it. The main start, you got the hand wheel behind the right side
Yeah,
pull up, but that's where it all starts.
Awesome.
Really neat stuff.
So I see we just got some comments coming in. Comments, questions, keep them coming. Got a couple more minutes and before we say goodbye to you guys, so.
R410A right now, Carlos.
Yeah, we're still at 410A. We'll be for a while.
You know, I've been seeing some stuff on social media with Daikin, and someone said R32 installing, you know, today, going in.
Yep.
So it's changing. Not everybody is adopting as quickly as others.
Right. And unfortunately, Jeff, I think we will see that probably that R32 before we see CO2, but it's definitely something. It's a conversation within the manufacturers, so it is. They understand what it can do, and they're talking about it. You know, unfortunately, you know, going from a refrigerant like a 410A or an R32 and then bumping up to a CO2, you think about it, it's not just a change in refrigerants. It's the components, the compressors, you know, it's everything in between, you know, the heat exchanger. So a lot of things got to get beefed up at that point. So it's definitely a conversation, though.
To go to your point earlier, water's been around for a million years, right?
Yep.
So if this outdoor unit, currently in this photo, let's say 10 years, life shelf, it's gone. I don't have to worry about anything inside the building.
Mm-hmm.
The power will be outside, really pumping and piping, so connection. You know, that standalone outdoor unit can be that you know, ever-changing piece of component.
Yeah. Oh, absolutely, absolutely. And I'm seeing is that Matthew there asking about who can help with a log cabin application. Depends on where you are, Matthew. Throw in the chat, let us know where that application is. If you're in our territory, we can certainly help you. If not, we can at least get you the contact info over at Space Pack where they can, you know, send you to that, you know, that person.
Yeah, if it's a cabin in Wading River, we can help you.
Yeah, we'd love to do that. Pennsylvania, Central PA,
Yeah.
or New Jersey. Yeah, we can help you in New Jersey for sure. Absolutely, yeah. Send us an email, or we got your information. We'll have somebody get in touch with you, and if you have those applications, I mean, it doesn't really matter. You know, log cabin's awesome. That'd be a lot of fun to do. You know, they've done them up north. Really just comes down to your load, right?
Matt, who's your wholesaler too? For us, it's service provided for you know, regional in our area, sales. Right? We play nice with others, but it's always good when we can reach out and touch you on other jobs as well.
So Brian, that line set on a split system, that's going to be, I want to say it's 25 to 35 feet
35.
35 feet, yeah, so it comes with a 35-foot line set. That's the max, so we don't have a long distance we can do, and that's one of the, the cons, I guess you can say, of refrigerant, right? We have these limitations on the compressor and everything else, where in the monoblock systems, we have no limitations, it's creativity and size of the pump, which we can do all day. But yeah, that's gonna be 35 feet. Still a decent distance, you're putting that thing outside and coming through a wall and going into a mechanical room, definitely see a lot of good applications for that.
Well, if you think modern day boilers, they go right to an outside wall with their venting. So think of the venting and our limitations are line set. So it's relevant maybe where you need to put the indoor source, right, in respect to a condensing boilers.
Absolutely.
35 is, it sounds short, but it really isn't.
Very good, Matt. We will. All right. We've still got some good questions coming in.
Normally the 50-foot rolls. Yeah, they'll provide the line set.
Yeah, it's the one nice thing. SpacePack does provide all of that stuff. So
you can certainly cut and have a couple of beers on the weekend with the scrap.
Yeah. You don't have to worry about providing your own. So you will get the 35 feet with the control cable. So that's all provided with the system. So nothing to worry about there. All right. Very good. Looks like we got just some comments coming through. So again, you have our emails in that handout section. Don't forget to take that information that's there. It's all great information, as well as the contact sheet. You can get in touch with myself or Anthony or anybody at Wales Darby there. So you'll see some of the other manufacturers we do represent. So if you do have other questions and you want to send us an email, you want to reach out to us again on social media, feel free if you caught us there. But it's great having you guys today. We got a couple more in, or?
Could you go over hookup again on the refrigerant side? Yeah, Joseph, what are you referring to? Hooking up what?
Yeah, there's only two connections, inside, outside, when you're talking about the split system.
Flares maybe.
Oh, okay.
I think that's what you're saying. Can you go over a hookup again on the refrigerant side?
The connection side to them, I believe, is all braids. I don't even think it is flare in that system. I could be wrong, but yeah, it could be.
I don't know
wrong.
if we went over today, but I did cover, there was another option with traditional heat pumps. One of our manufacturers, they have their solution. So they provide the inside, and then you can go with a more traditional two-stage variable speed condenser heat pump.
Right.
So it's a mixed match, but there might be maybe more options with longer distances with that. So you got to check those particular manufacturers, whatever one you're working with.
Absolutely. Yeah, if you need more info, Joseph, definitely shoot us a message. You can definitely reach out offline and get something you're looking at. What we will be doing, we like doing the certification classes, especially on this stuff. If air or water is something you're definitely interested in, definitely reach out to us at Wales Darby, and we can set up a certification class. We do both the air side on a small duct, and we do a separate, hydronic certification. So it gets you guys some extra benefits there. It gets you some leads and stuff like that too. So we have those abilities. And the same thing, you do sort of take a system if that's something you had interest in. We have some opportunities to get you up to the factory, do some training up there. So if you have those nice passive home tight applications and, good quality work, we'd love to talk to you. So
absolutely. Let's take a road trip.
All right. Well, with that, I'm going to say thank you guys for joining us. We will be back at it again next week. I believe we're doing, remind me again, Ann, are we doing a heat pump domestic next week or water conditioning? It's one of the two. You can register for our Wednesday webinars at our www.walesdarby.com website. You'll find all the registration there, as well as the emails that we send out to you guys. So you should be able to get those fairly easily. So if you have questions, you definitely give us a shout.
Okay, we'll say today's training is over. Doesn't mean training ends.
That's right. That's right. So if you don't forget those handouts.
So look forward to seeing you guys next week. Thanks for joining us.